Hello everyone, welcome to this new video. So this is the third video of problem of the day. So I have come with an exciting problem, another exciting problem. So till now I was discussing the 3D geometry as well as maxima minima part, which is differential calculus part, as well as I have discussed the 3D geometry, that is coordinate part. So now I have come to integral calculus part. Okay, so this question is basically of manipulation, that's it. So many don't know how to manipulate that. Only that's the reason that I've took this question. And basically this is very exciting problem. Like it gives you a very interesting method to solve such ratio type problems, especially in this integral calculus. So that's the sole reason that I have taken this problem in this video. So let us start our today's video. So this is the problem. So integral 1 is, the first integral is 0 to x e power tx into e power minus t square dt, and second integral is e power x square by 4 0 to x e power minus t square by 4 dt. So this is integral 1 and this is integral 2. So they ask us the ratio of integral 1 by integral 2. Basically we have no clear idea like how to start with, because from seeing the one and second like first one and the second one, we don't see any clear relation. Like it's not a clear ratio so that we can just divide them and get the answer. No, it's not like that. So any type of problems of this model, okay, if even if it's gonna be framed in any of the exam or any of the competitive olympiads, the only thing that you need to do is manipulation. Okay, this is the system, this is what you need to do, because without manipulation you can't operate integrals in division, isn't it? So you need to manipulate any one of the integral and get it into the other form. So it might be multiplying with something or modifying the terms that are there in the original integral. So it depends, like we must try for that. So basically there is an extra component in integral 2. If you look at it, you can see that there is an extra component of e power of e power x by 4 here. Wait a minute. Uh, Extra component of e power x by 4 here. So that's the reason. So what we need to do is we need to yeah now it's working. So you need to so if I look at it, I find an extra term, that is e power x square by 4 in the second integral. So I feel like there must be something that must be modified in the integral 1 to get it in the form of integral 2. So that's the reason I will start my first step from the integral 1 itself. So coming to the solution, so let's get into the next page. So we know the integral 1 is 0 to x e power tx into e power minus t square dt, isn't it? So this is the integral, first integral. So by looking at that, we can just come to a conclusion that let us take the common in the power, with the regards of power. So you get 0 to x e power tx minus t square dt, isn't it? So we can write this in this form, isn't it, guys? So t square, like it's in a form of quadratic, so it will be comfortable if you write it in this way: 0 to x minus t square minus tx, because always coefficient of x square or t square or degree of 2 coefficient must be positive, so that it makes our work easy. Basically that's the only reason I have taken this. So 0 to x e power t square minus tx dt. Now we can write that in a quadratic form, isn't it? Like in a whole square form. So I'll be doing that because we are left with no other operation that can be done. This is the only sole operation that we can do and get it into the form of second one. Because if you see in the second one, if you see the second one, you can find there's a term e power minus t square by 4. So here how to get a t square by 4 is just to make it into a form of square, a plus b whole square form. If you make that, we can have a chance of getting t square by 4 coefficient, like a term. So if I do that, it's nothing but e power minus whole t minus, okay, this is it's t minus x by 2 whole square minus x square by 4 okay, x square by 4 dt, isn't it? So this one I can write it in this form, right? T square plus x square by 4 minus t square plus x square by 4 minus tx minus x square by 4. So this is nothing but this. So this I have written it in this form. That's it. So now this is basically nothing but e power. So if I see that carefully, I can write it in this way: 0 to x e power minus t minus x by 2 whole square, isn't it, into e power minus x square by 4 dt, isn't it? So I can write it in this form, right? So basically it's minus of minus plus. Okay, it's minus of minus plus. So this whole thing I've written it in this way. Just I've divided, like I made this into a combination of 2 instead of 1. That's it, nothing else. So from here I can take this component outside of the integral, isn't it, guys? Because here it is e power x square by 4, which is independent of t, right? There's no t term in this term, like there's no component of t in this term, so I can take it out because there's nothing dependent of integral on this term, so I can take this out. So that's the logic. And here we are halfway done, because if you see the second integral, we find e power x square by 4. So we are halfway done, and we can be sure that our process is right. So just take e power x square by 4 common, like just take that out of the integral. You get e power x square by 4 integral 0 to x, okay, integral 0 to x, that is e power minus t minus x by 2 whole square dt. So this is what we are left with. And now there's an interesting property that we need to make a note of. Okay, there's an interesting property, because the things that have been given in the second integral is t square by 4, but we have t minus x by 2 whole square, isn't it? So we need to make some changes. So I can write this, I'm using that property which I'll list it out later. So it's basically 0 to x. So instead of 0 to x, okay, I can write this as minus x by 2 to x by 2 into e power minus t square dt. Okay, the thing is, if the expression is like e power a plus x, okay, e power a plus x d, okay, here dA. So integral I am taking in this form, okay, integral e power a plus x, which is dependent on a, it's not dependent upon x, it's only dependent upon a, and the values are like so if you take the same system 0 to x, okay, 0 to x, it's nothing but whenever I take this term out, like if I take this out like in whole square, because it's not like we can directly take this out, if it's of whole square, so we can just write it in this way. X by, like if it's x, before we have x by 2, so we have reduced the 0 to x by 2 and x to x by 2, like there's a difference if I take this out. So it is in the same way, if I take this 0 x outside, I should make a difference of that. So 0 becomes minus x and x becomes 0, it's nothing but a square dA. So this is how you write it. Understood, guys? So this is a major property, very important property. Very less problems we see this property, but if usage of this makes a problem very easy to solve. So basically I have taken this x by 2 out, okay, but because it is a square term, I cannot take that out directly, isn't it? Because it's in the square, so I cannot take that directly. So I have used that property, like if I have taken this term out, I need to modify the limits. I need to change the limits, because I have taken x by 2, like I have taken the x by 2 term out, like I have taken out completely. So I must change the integrals limits, so that 0 is reduced to x by 2, so it becomes minus x by 2, and x is reduced by x by 2, so it becomes x by 2, isn't it? If I take x by 2 from here, I get minus x by 2. If I take x by 2 from x, it becomes x by 2. So that's what I have written. So this is a very important property. I hope you all will make a list, like we'll make note of it. So let's continue. Let me erase this. Yeah, so it's basically this one, and now this I can write it as, now there is another major property. Now I have taken the half out here, e power x square by 4, okay, e power x square by 4 minus x 2x, okay, e power minus x by 4 x by x into e power minus t square by 4 dt. So this is how you modify it again. So we have taken, like, we have changed the limits to x, and we have put it like I have made, like, I've changed the limits basically to a comfortable form, like from x by 2 I've changed the limits to x, and as well as at the same time I need to make sure the power of this, like the term that is independent upon integral, should also be changed, because I'm making it half whole square is 1 by 4, so that's the reason I've got it in this form, and because I'm making it half, I've got the half outside. So this is a very important form property again in definite integrals. So the basic thing is I'm changing the limits into comfortable form, like minus x to x, because it's by 2 to, like, it's from minus x by 2 to x by 2. It's the same thing if I go from minus x to x, there's nothing different. And now the only thing that I have done is I have changed this, like minus t square to minus t square by 4, and I have made that to half. Okay guys, that doesn't mean like we are changing anything, we are just using the property that I have made this like this t to t by 2. So that's the reason I took the half outside. So that's the reason, the basic like it's a basic understanding. So I hope you all understood this property. So it's basically nothing but half of into 2, okay, half into 2 e power x square by 4 0 to x e power minus t square by 4 dt. Okay, so I have done is minus 2x is nothing but 2 into 0 to x, 2 into integral from 0 to x, because this is, if you keep x or if you keep minus x, you get the same result. So it's an even function basically, if we talk like if we talk in the reference of the function. So that's the reason I have taken from minus x to x as 2 times 0 to x. So I have taken the 2 outside, so we get e power x square by 4 0 to x e power minus t square by 4 dt, isn't it? So if you examine this, this is nothing but I2 integral 2, isn't it? So if I go here, so I1 by I2 is nothing but 1. I hope you understood this, guys. So this is very important problem, a very conceptual problem. Like there are two main properties here. These two properties play a vital role in your understanding. These two properties, like how did I change from this to this and this to this. So you just make sure you see this video for twice or thrice in this moment, like this moment, so that you get a better understanding of the usage of properties. So it's basically a important rule that many books avoid this, many books don't tell this, but it's very important rule that and applying them is the only sole way to get to the end of the problem, not it's highly impossible to solve this type of problem. So the modification required, so basically t minus x by 2 are made into t, and for that we need this property. And second thing, t to t square by 4, and again we need this property. So definitely it makes a lot of change if we don't do that, because x by 2 to x by minus x by 2 to x by 2, there's this much. Like if I take a graph in this way, okay, minus x by 2 to x by 2 would be only this much, but minus x to x would be this much. So area, there's a change, isn't it? Minus x by 2 to x by 2, the graph only, like the area only will be this extent, but minus x to x, this will be the area will be in this way. So at the same moment, because we are changing to minus x by 2 to minus x and x by 2 to x, we need to even change the integral inside, so that the area remains the constant. We shouldn't extend the area. We must make sure the area remains the same. The different integral is nothing but this area, isn't it? So we must make sure the portion of the graph remains same. So that's the reason we got e power minus t square to minus t square by 4. If it is only t, okay, if it's only t, then we would have got only t by 2, okay, because we are making sure like we are doubling the limits, upper limit and lower limit. So we need to make sure we even divide say with the same quantity inside the integral thing, okay, because we have doubled the limits. We have doubled the limits. 2 into minus x by 2, it's minus x. 2 into x by 2, it's x. So at the same time we made sure that the inside integral also became half, okay, like the term that's dependent of t had become half. So that's the thing that you need to make sure, and there we need to write half also, half here itself. So that's a very important property. I hope you all understood this. So I'll be coming with another exciting problem day after tomorrow. So signing off now. If you have any doubts, you can just comment them. I'll clarified and make sure it solves you to the better extent. Thank you.